Good morning, everybody. My name is Miss Angell, and I'm one of the science teachers here at Kelvin Hall School. And today I'm going to be teaching you some physics. So if you could open up your booklets and find the lined paper, you should also have a worksheet that we're going to use today too. I'm going to point out now, today we are going to need to use calculators, so your teacher may want to pause the presentation so you can hand those out. Okay, so on your piece of paper, could you please write today's date and the title, gravity and mass? So by the end of today's lesson, we aim to answer today's big question. Why is my weight different on Earth compared to the moon? Now, to get you in the physics feel, I would like you to write down 3 things that you know about forces. It might be what forces are, some names of them, or what they do. Write them down on your piece of paper, and your teacher can pause this presentation and take some feedback. Okay, so I hope we've got those creative juices flowing now. So by the end of today's lesson, we should be able to state that gravity is a non-contact force that will affect objects within the gravitational field. We should be working towards describing how the gravitational field strength of an object changes due to size or mass of the object. And we're going to really push today, Year 6, to calculate weight when given mass and gravitational field strength. Okay, so on your worksheet, you have got a table titled Activity 1. Should say contact and non-contact forces. I would like you to put these forces into the correct place. So I'll go through them now, and then your teacher can pause so you can complete this activity. So the first one, we've got gravitational force, friction, tension, electrostatic, normal contact force, air resistance, and magnetic force. So please ask your teacher to pause the video. Talk with the person next to you so you can answer these questions. Okay, so let's go through these answers then. I'd like you to mark your own. So gravitational force is an example of a non-contact force. Friction is a contact force, as is tension. We need 2 surfaces to be touching in order to get this force. Electrostatic force is non-contact, and normal contact force, this one might have been quite easy, is a contact force. Air resistance is also a contact force, and magnetic force is a non-contact. So how did you do? Can you give yourselves a score out of 7, please? Great job. Okay, so moving on. We've already hit our target grade 3 because we now know that gravity is a non-contact force. So we're going to talk a little bit about some terms that sound very similar but mean very different things. Let's have a look at the picture then. So we've got people stood all around planet Earth. They all have a ball and they keep saying, this ball falls down at my feet. Why is that? What is gravity? So gravity is a force that pulls objects towards the centre. That's why your feet are on the floor. And when our Earth rotates, you don't just fall off the side of the planet. Mass is another key word that we use, but sometimes we can get confused with this. So mass is a measurement of how much of something there is. So how many particles are inside you, or how many particles are inside that dumbbell. We measure mass in grams and kilograms. So, what is weight then? Because my weight on Earth is around 560 newtons. But if I was to go to the moon, my weight would only be 90 newtons. Well, weight and mass are not the same. Mass is the amount of matter. We've said this before. So if I was to go to the moon, I would still weigh the same amount. I'll still have 55 kilograms worth of particles inside of me. But weight is a force, and it's a force caused by the pull of gravity. So my weight would be something on Earth, but if gravity is different on the moon, then my weight is also different on the moon. So let's have a look at this T-Rex then. He is always going to weigh 1,000 kilograms. That's always going to be his mass. But his weight, which is a force, is going to change if gravity changes. Let's have a look then at activity 1 on your worksheet. So you have got a table. It says mass and weight. And I want you to decide which of these statements go in which box. Your teacher can pause now to give you time to do this activity. So let's see how we've got on. Let's see if we can mark our own, please, Year 7. Mass. What is mass? Well, mass is how much matter or how many particles an object has. So what is weight then? Now, we said weight is a force acting on an object due to gravity. What do we measure mass in? We should have got kilograms, which means we measure weight in newtons. And how is it measured? So we measure our mass, how many particles are inside of us, by a balance or a scale. But we measure the weight of something by a special device called a Newton meter. How did you do, guys? That how is it measured question was quite tricky. How many did you get correct? Okay, great job. Look at this. On target for a grade 5, because we now know that it's gravity that is affecting the weight and not the mass. So, tricky part, let's work towards our grade 6. We now know weight is a measurement of force and we measure it in something called newtons. The same way that we measure time in seconds, but we measure force in newtons. On your piece of lined paper, can you please write down this calculation because you're going to need it today. Weight equals mass times acceleration of gravity. Your teacher can pause here just to give you a little bit of time. So let's have a look at our T-Rex example again. The T-Rex has a mass of 1,000 kilograms. And on planet Earth, the gravity is 9.8 meters per second. So I'm going to do mass times acceleration of gravity. 1,000 times 9.8. So use your calculators, pause the video and feed back to your teacher. Great job, everybody. Now, let's have a look at our worksheet. I've given you the T-Rex on 6 different planets. I would like you to calculate his weight. There is a space for you to write down your working out and a space for your answer. Pause the video here so you can complete this activity. Right, let's mark our work. I'd like you to mark your own. So how much would the T-Rex weigh on the moon? So we do 1.6 times 1,000 should give us 1,600 newtons. Saturn, he would weigh 10,400 newtons. And on Mars, 3,700 newtons. Let's look at Venus then. So the gravity is 8.8, so it should be 8,800 newtons. And on Jupiter, 24,900 newtons. And gravity on Neptune is 11.5, so he would weigh 11,500 newtons. Can you give yourself a score out of 6, please? Well done, Year 6. Great job. Any that you've got wrong, can you see where you went wrong? Did you times it by 10 or times it by 100 by accident? Now we've done this nice introduction, we're going to go back to lined paper. And I'm going to set you guys a challenge. I want to know how much I would weigh on different parts of our solar system. So there's a collection of stars and planets and moons on the screen now. We're going to use the calculation. Weight is mass times acceleration of gravity. Now, my mass is always 55 kilograms. So I would like you to calculate how much I would weigh on all these different places. But I've also given you 3 challenge questions. Can you find out which part of our solar system I would have the biggest weight and the lowest weight? And I also have a Brucey bonus challenge here. I want to bring my dog, Harvey, with me to space, and we are going to go to Jupiter. I know his weight on Jupiter is 240 newtons, and I want you to try and work out what his mass would be. So pause the video now and try and attempt this challenge. Okay, right, let's see how we've got on. Can you now swap your work with somebody that you are sat close to? Because this time you're going to mark their answers. Okay, so we should have, I'm going to fire through these. 66, 539, 71.5, 77, 99, 1,364, and now Mars and Mercury both have 203.5. 88, 638, 583, 77, 44, and Uranus and Venus both have a weight of 489.5. Okay, so let's mark that section and give them a score. Let's see who attempted these challenge questions. So, in which part of our solar system would I have the biggest weight? Well, looking at it, it's going to be Jupiter with a whopping 1,364 newtons. Which part of our solar system would I have the lowest weight? Well, that would be on Triton. Now, let's see who went for the Brucey bonus challenge here. I want to bring my dog, Harvey, to visit me when we're going to Jupiter. I know that his total weight on Jupiter is 248 newtons. So you had to find out his mass. Now, looking at the table, I know that the gravity on Jupiter is going to be 24.8 newtons per kilogram. So to work out his mass, I do weight divided by gravity. So 248 divided by 24.8 means my little furry friend Harvey has a mass of 10 kilograms. Well done to you all who attempted these challenge questions. So we've been able to reach our target grade of a challenge 6, calculating weight. Let's go back over and see what we can remember. I'm going to ask you 6 questions, and then I want you to talk about them with your friend before you feed back to your teacher. So true or false? Mass is measured in grams and kilograms. Weight is the same as mass. The moon orbits the sun. Gravitational force changes on other planets. You weigh less on the moon, and your mass changes in space. So talk about them with your friend, write down your answers, true or false, and pause the video so you've got a little bit of time to do this. So let's see, true or false? Mass is measured in grams and kilograms. That is true. Weight is the same as mass. Absolutely not. That is false. Ooh, question here. The moon orbits the sun. That is false because the moon orbits Earth. Gravitational force change on other planets. That is true. Your mass changes in space. False. And you weigh less on the moon. True. Tried to trick you up there. So well done. We should hopefully have got at least 4 of those correct. Next challenge then, on your line piece of paper, I want you guys to show me what you can now do. So start at the bronze and answer these questions from bronze, silver, all the way to gold. And when you get to gold, I would like you to explain your answer. Here's a good time for your teacher to pause the video so that you have time to answer these questions. So this time, marking our own work. Contact forces. Today we've looked at friction, tension, and air resistance. And non-contact, we looked at gravity, magnetism, and electrostatic force. And what was that equation again to calculate weight? Mass times acceleration of gravity. And the gold question, do I weigh more on the moon? And I wanted you to explain your answer. So it's not enough to just say yes or no. You've got to tell me why. So the mass would be the same, but weight would be different because weight is the effect of gravity on an object. Okay, so big question from today's lesson. Why is my weight different on Earth compared to the moon? Can you answer this now? Pause the video and ask your teacher to test you. Can you answer this question? Oh, I hope there was loads of hands up there. I hope there was lots of correct answers. So our weight is different because gravity is different. So just to finish off then, we're going to do a little bit of reviewing of our learning. It's important that we do this to close our brains back in and to make sure that we keep all this information locked in. So on your piece of paper, write 5 sentences summarizing today's topics using all the keywords you can think of. If you're not sure, look at the top of the slide. I've put some keywords up there for you. I then want you to take those 5 sentences and choose 5 keywords. And then I want you to summarize what you think is the most important keyword we've done today. So again, pause the video so you've got some time to think about this. Okay, really well done, Year 6. Unfortunately, this is obviously not the way we wanted to meet, but nevertheless, I hope you've enjoyed your week of science lessons. And we all look forward to seeing you in September. Enjoy the rest of your term and the summer holidays. Stay safe, and I look forward to seeing you soon. Thank you very much, guys. Goodbye.